Okay, homework 31. We are solving trigonometric equations involving an angle multiplied by a constant. So we have something like 2 sine of 1/2 x equals -1. Again, oops, you are going to want to have your tables handy so that you can look up your values as you go. So make sure you have that table. You'll need that a lot. So over here, what we're first of all going to do is solve this. And so I'm going to have 2 sine of 1/2 x equals a positive 1. So sine of 1/2 x equals 1/2. What we're going to do is look up where the sine of x equals 1/2 and then go from there and set this equal to each of our values. So looking here, where does the sine of x equals 1/2? At pi over 6. And if I look down, 5 pi over 6. So normally what we have is pi over 6 plus 2k pi and 5 pi over 6 plus 2k pi, with of course k being an element of z. However, we are now going to say, instead of this answer, 1/2 x is equal to that answer. And so what we need to do to solve these is multiply by the 2 to get the x by itself. So we're going to times 2, same thing down here, times 2, times by our 2. So when we times by 2, 2 times pi over 6 would be pi over 3, plus 2 times 2k pi would be 4k pi, with k being an element of z. So I distribute that and take the 2 times the this and 2 times this. Same thing here. When I multiply this by 2, the 2 would cancel out with that, make that 5 pi over 3, plus 2 times 2k pi would make that 4k pi, with k being an element of z. So I'm going to have those two answers, pi over 3 plus 4k pi with k being an element of z, or 5 pi over 3 plus my 4k pi plus k being an element of z. So solve it like you normally do. Find or put x in there. Once you get your answers, then you're going to replace the x with whatever's in the parentheses here and solve it from there. So if we look at number 2. Number 2, if we solve that, we would have the tangent of 1/2 x equals square root of 3. So we're going to look up, where does the tangent of x equal the square root of 3? Tangent equals square root of 3 at pi over 3. It's also equal to the square root of 3 at 4 pi over 3. But remember, tangent normally has a period of pi, and so we usually combine that into one answer as pi over 3 plus just k pi, with k being an element of z. So in this case then we are going to say 1/2 x equals that. In order to solve it for x, we're going to times by 2. So I'm going to have 2 pi over 3 plus 2k pi, with k being an element of z. And that's going to be my answer. So on number 3, if we go ahead and solve that one, we would say 2 sine of 2x equals -1. So the sine of 2x is going to equal -1/2. Again, we're going to look up, where does the sine of x equals -1/2. And so looking at my paper, -1/2 would be at 7 pi over 6, and -1/2 is also at 11 pi over 6. Again, we can't combine those into two answers, so we are going to say this time we have a 2x here. 2x can either equal 7 pi over 6 plus 2k pi, with k being an element of z, or 2x is going to equal 11 pi over 6 plus 2k pi, with k being an element of z. So if we're going to solve these ones, we are going to divide by 2, which is multiplying by 1/2 in order to solve those. So we're going to take half of those. So in this case, I would have 7 pi over 12 plus here 2 and 1/2 is going to make that just 1k pi, or just k pi, with k being an element of z. Here I would get 11 pi over 12. Again, when I take the 2 times the 1/2, it just gives me 1. So I just have k pi with k being an element of z. So 7 pi over 12 or 11 pi over 12 plus k pi with k being an element of z. 4, 5, and 6, same kind of thing. I'm solving trigonometric equations. These ones, I'm going to leave them between the intervals 0 and 2 pi, so I won't have to have that weird k pi stuff at the end. Still having that fraction or even a whole number in there with my x, but solving them like I did on the previous ones. Again, I want to have my table handy so I can look up my values as I go, so make sure you have your table. And so if I go back here to number 4, I'm going to start my solving and saying that the sine of 2x over 3 is equal to 1. So I'm going to look for where the sine of x equals 1. So looking at my paper, I have pi over 2. And that looks like that's the only thing I have is pi over 2. And so I'm going to say 2x over 3 equals pi over 2 plus normally 2k pi with k being an element of z. So solving that, I would have to multiply by the reciprocal 3 over 2. So I'm going to get 3 pi over 4. The 2's would cancel out, so plus 3k pi with k being an element of z. Now they don't want all of this on here. They want only the ones between 0 and 2 pi. So what you have to start doing is figuring out, okay, if k is 0, this is going to be gone. I just get the 3 pi over 4. If k is 1, I would take 3 pi over 4 plus 3 pi. Now if I add 3 pi to 3 pi over 4, I'm going to be out of this range. I'm going to be past the 2 pi because I'm adding 3 pi to it. So this is going to be my only solution that ends up being between 0 and 2 pi. And so in this case, I just have the one answer, 3 pi over 4. So if I look at number 5, same kind of thing here. If I solve this, I would say the cosine of 3x equals a positive 1. So I'm going to look up where the cosine of x equals 1. So cosine of x equals 1 at 0 and not till 2 pi. So again, we normally would combine that and say 0 plus 2k pi with k being an element of z. But this time we're going to say 3x is equal to that. So if I want to solve this for x, I'm going to multiply by 1/3, which is the reciprocal of your 3. So I'm going to times by 1/3. Well, 0 times 1/3 is 0, plus 1/3 times this would be 2k pi over 3, or 2/3 k pi, with k being an element of z. Now I want to find all the answers between 0 and 2 pi. So I'm going to start, if I put 0 in for k, this will be gone. I just get an answer of 0. If I put 1 in for k, I'm going to get 0 plus 2k pi over 3. Well, 2/3 is between 0 and 2 pi. So 2 pi over 3. When I put 2 in here, I'm just going to add another 2 pi over 3 because each time I'm adding 2 pi over 3. So now I'm going to add my 2 pi over 3. That's going to give me 4 pi over 3. 4 pi over 3 is still between 0 and 2 pi. So then I'm going to add another 2 pi to that, 2 pi over 3. So I would end up with 6 pi over 3. Well, if I'm at 6 pi over 3, that's exactly equal to 2 pi. And I don't want to have the equal 2 pi because I have that parenthesis instead of the bracket. And so I'm done. I found all of my angles between the 0 and 2 pi. So 0, 2 pi over 3, and 4 pi over 3 would all go in for your answers. So on this part, just think of it as starting with this. Ignore the k is there because the 0 is going to give you the first term. 1 will just give you that. And then each time you're adding another one of those on there. So I added 2 pi over 3. I added a second 2 pi over 3. I added a third 2 pi over 3. And I would keep going until my answer was larger than 2 pi. Let's try that again on number 6. So number 6, if I solve this, I'm doing cotangent of 3x over 2. That would equal a negative square root of 3. So I'm going to look for the cotangent of x equals negative square root of 3. So cotangent column, negative square root of 3 is at 5 pi over 6. If you keep looking down the list, I also have it at 11 pi over 6. But keep in mind, since it's a cotangent, the period should be pi. If I take 5/6 plus 1, I get 11/6. And so normally I'm just going to say 5 pi over 6 plus k pi, with k being an element of z because tangent and cotangent have a period of 180 degrees, or pi, each one. That's going to equal my 3x over 2. And so if I'm going to solve that, I'm going to multiply by 2/3. So, reducing 1 and 3 gives me 5 pi over 9, plus I still have to take the 2/3 there, so 2k pi over 3, with of course k being an element of z. So, if k is 0, I'm going to have 5 pi over 9. So I have 5 pi over 9. I'm going to add 2/3 pi. So if I add 2/3, since I'm in ninths, timesing by 3, I would have 5 pi over 9 plus 6 pi over 9. Same thing as 2/3. So that's going to give me 11 pi over 9. 11 pi over 9 is less than 2 pi. I'd have to get up to 18. So again, I'm going to have my 11 pi over 9, which was this answer. I'm going to add my 2 pi over 3, which I changed to 6 pi over 9. And if I add that together, I get 17 pi over 9. That's still less than 2 pi. 9 goes into 17, 1 and 8/9. I'm not quite to 2, right? If I take my 17 pi over 9 and add another 6 pi over 9, then I'm going to be too big. That's going to be more than 2 pi. So those are going to be my 3 answers that I ended up with that end up being between the 0 and the 2 pi. So I had 5 pi over 9 plus 2/3 gave me 11 pi over 9, plus another 2/3 gave me 17 pi over 9, plus another 2/3 is too big. So I was done. Seven, 8, and 9, we're finding solutions in our interval. This time we're going to use our sum and difference formulas. And so, not only are we going to need our handy-dandy table that we usually have, you'll also want to have your sum and difference identities. So, sine of A, cosine of B, plus cosine of A, sine of B is the sine of A plus B, and so forth. Mostly we'll just use the sine and the cosine ones, but those are the ones you want to have, those sum and difference formulas. Again, keep those handy. I'm not going to switch back and forth because it erases my board, but you will want to have the sum and difference formulas. So if you don't have them, go to the resources, to the dictionary, type in sum or difference, and it should give you that as one of your choices, so you can print those out or find them in your notes from before. We have used them before. And so going over here, whoops, going over here, if I can get over here, we have the sine of 3x cosine of x plus cosine of 3x sine of x. So sine, cosine, plus cosine, sine. If you look at your sum and difference formulas, that's the sine of a plus b. So I'm going to have the sine of 3x plus x, which is going to be the sine of 4x to equal our 1. Now we're going to do it like we did the previous problems. We're going to pretend that we're just going to do the sine of x equals 1 and look those up. So on my paper, where does the sine equal 1? Pi over 2. And that's my only answer, pi over 2. So normally we have pi over 2 plus 2k pi, with k being an element of z. However, we're going to use 4x instead of x. I should have left myself a little bit more room. 4x is equal to that. So in order to solve that, we have to multiply by 1/4. So I've got to take 1/4 times that. Well, 1/4 times pi over 2 would be pi over 8, plus 1/4 times 2 would be 2/4 or 1/2. So k pi over 2, with k being an element of z. Again, we want all of the answers between 0 and 2 pi. So if this is 0, we just get our starting one, which is pi over 8. We're going to add 1/2 pi each time. So if I have pi over 8, and I add pi over 2, in terms of eighths, I would have 4 pi over 8. So pi over 8 plus 4 pi over 8 would be 5 pi over 8. Then I'm going to take my 5 pi over 8. I'm going to add my pi over 2, which is the same thing as 4 pi over 8, which gives me 9 pi over 8. Still less than 2 pi. So I'm going to take my 9 pi over 8, add my pi over 2, which is the same thing as 4 pi over 8. That gives me 13 pi over 8. Still, that's less than 2. 13 divided by 8 is 1 point something. So 13 pi over 8. We'd have to get to 16 to get to 2 pi. So 13 pi over 8 plus another 4 pi over 8 is 17 pi over 8. Ah, that's bigger than 16. That one's too big. So these are going to be our 4 answers if we're trying to stay between 0 and 2 pi. Pi over 8, 5 pi over 8, 9 pi over 8, and 13 pi over 8. So we started with our beginning value. We added 1/2 pi, or pi over 2 each time. You could use your calculator, 1/8 plus 1/2, plus 1/2, plus 1/2, plus 1/2, till you get too big. Number 8, same kind of thing. I have 2 sine of 5x cosine of x minus 2 cosine 5x sine of x. If I factor out the 2, I would have sine of 5x cosine of x minus cosine of 5x sine of x equals 1. So if I divide by that, I would have sine of 5x cosine of x minus cosine of 5x sine of x equals 1/2. This again is one of my formulas. Sine, cosine, minus cosine, sine. So if you look up your sum and difference, for sine and cosine minus cosine, sine, it is the sine of a minus b, so 5x minus x. Trying to subtract already. 5x minus x to equal my 1/2. So the sine of 4x would equal 1/2. Again, we're going to look up where does the sine of x equals 1/2. So sine equals 1/2 at pi over 6. I'll put plus my 2k pi. And then also equals 1/2 at 5 pi over 6. Again, that's just equal to x. We really want to have 4x equals that. So we're going to multiply by 1/4 to solve. So this would give me pi over 24 plus this would be pi over 2, k pi over 2. This is going to give me 5 pi over 24 plus, again, that would reduce down. 2/4 is the same thing as 1/2, so k pi over 2. But of course they don't want it in that form. They want every single angle that's between 0 and 2 pi. So I'm going to start with pi over 24. Because if this is 0, I would get pi over 24. I'm going to keep adding pi over 2. So if I add plus pi over 2, that would be 12 24ths. So 1 24th plus 12 24ths would be 13 24ths. So I'm going to take my 13 24ths plus 12 again 24ths, which gives me 25 24ths. So 25 pi over 24. 25 24ths plus 12 24ths would give me 37 24ths. I'd have to get to 48 to be too big. So 37 24ths plus 12 24ths would give me 49 24ths. That's going to be more than 2 because I'd have 48 would be double, so that'd be too big. So I'm going to have those 4 answers from just this. I still have to do this one. So going over here, I'm going to have 5 pi over 24. I'm just going to add it over here. 5 pi over 24. So I'm going to take my 5 pi over 24. I'm going to add pi over 2, which again was 12 24ths. So 5 plus 12 would give me 17 24ths. 17 pi over 24 adds to my list. So 17 24ths plus 12 24ths would give me 29 24ths. So 29 pi over 24 added to my list. Plus 12 24ths again would give me 941. That's still small enough because 48 would be too big. 41 pi over 24. And then if I add another 12, I'm going to be at 53 24ths. That one's going to be too big for sure. So I'm going to have 8 answers. Pi over 24, 13 pi over 24, 25 pi over 24, 37 pi over 24. Then for my second set, 5 pi over 24, 17 pi over 24, 29 pi over 24, and 41 pi over 24. So all 8 of those things are going to go in for my answers. I got 4 from the first one, 4 from the second one, that all fit between 0 and 2 pi. Number 9. This time we have cosine of x, cosine of 2x, minus sine of x, sine of 2x equals -1. So again, if I look at my difference formulas, cosine, cosine, minus sine, sine, means I'm going to have the cosine of a plus b if I look at my formulas. So cosine of a plus b would be x plus 2x to equal my -1. So the cosine of 3x would equal -1. Of course, we're going to start by looking where does the cosine of x equals -1. So on my paper, cosine of x equals -1 just at pi. Pi plus 2k pi with k being an element of z. 3x is going to equal that. So in order to solve that, I'm going to multiply by 1/3. So I'm going to have 1/3 pi plus 2k pi over 3, with, of course, k being an element of z. So 1/3 pi is the same thing as pi over 3. I'm going to add 2/3. So 1/3 plus 2/3 would be 3/3, which would just be pi then. Right? 3/3 is the same thing as pi. Pi plus 2/3. 3/3 plus 2/3 would be 5/3. So 5 pi over 3. 5/3 plus 2/3 is 7/3. 7/3 is too big because 6/3 would be 2 pi. So pi over 3, pi, and 5 pi over 3 would be your answers. So if you're bad with fractions, use your calculator. Pi over 3 is the same thing as 1/3. 1/3 plus 2/3 gives you 3/3, or pi. Pi plus 2/3, 1 plus 2/3 is 5/3, and so forth. And so I'm going to keep going until I get bigger than 2 pi, which in this case would be 6/3 is the same thing as 2, so I stop there at 5 pi over 3. All right, 10, 11, and 12, we're still using the sum and difference identities. We're just going to work them backwards this time. So again, you're going to want your sum and difference ones. So if I have the sign of a plus b, I'm going to change it to the sine of a, cosine of b, plus cosine of a, sine of b, and so forth. Normally just using the sine and the cosine ones, but keep those handy. We're going to take it from this form, put it into this form, and simplify our equations. So, first of all, we have cosine of x plus 2 pi plus cosine of x minus 2 pi equals 1. So for cosine of a plus b, we're going to take the cosine of a, cosine of b, minus sine of a, sine of b. So cosine of x cosine of 2 pi minus sine of x sine of 2 pi. So that's just for this part right here. Plus, this time we have the cosine of x minus 2 pi. So it's going to be the cosine of x, cosine of 2 pi, but it's going to change to plus because that sign will be different, because if you look at your formula, it'll be a plus in there. So I'm going to have cosine of x, cosine of 2 pi. Since this is a minus, this is going to change to plus sine of x, sine of 2 pi. And of course, that's still going to equal the 1 that I had way on the end. Looking at that, the signs are going to cancel out. So this will cancel this out. These two are the same. So I'm going to have 2 cosine of x, cosine of 2 pi equals 1. Cosine of 2 pi. Now you're going to look up in your table that we've used before. I'm going to look up the value for cosine of 2 pi. So cosine of 2 pi way down at the bottom is equal to 1. So I'm going to replace this with 1. So I get 2 cosine of x equals 1. Solving that, cosine of x equals 1/2. We are going to do it with that weird notation that we have up here with the 2k pi, since it's the cosine. If I look for 1/2, we have pi over 3. And if I keep looking for 1/2, I have 5 pi over 3. So we're going to have, didn't mean to put the comma there, pi over 3 plus 2k pi, with k being an element of z, or 5 pi over 3 plus 2k pi, with k being an element of z. And those would be our solutions. So number 11 is going to be the same kind of thing. This time we're using the sine ones. So on your sine ones, you have sine, cosine, cosine, sine. So sine of x, cosine of 2 pi. This is plus, so plus cosine of x, sine of 2 pi plus, this is going to be sine of x cosine of 2 pi. Since this is a minus, we got a minus cosine of x sine of 2 pi equals negative 1. Get all that in there. Looking at that, this time cosine of x sine of 2 pi is going to cancel out. These two are the same, so we're going to have 2 sine of x cosine of 2 pi equals negative 1. Cosine of 2 pi, we looked that up before, but if you look it up again, cosine of 2 pi is equal to 1. So we're going to put a 1 in here. So we get 2 sine of x equals negative 1. So sine of x equals negative 1/2. And we're going to look those up. So sine of x equals negative 1/2 at 7 pi over 6. Also equals negative 1/2 at 11 pi over 6. So we're going to have 7 pi over 6 plus 2k pi, with k being an element of z, or 11 pi over 6 plus 2k pi, with k being an element of z. Those would be the values where our sine of x equals negative 1/2. Number 12, we're doing cosine and cosine again. So when we have the cosine, cosine, we have cosine, cosine, and sine, sine, opposite sign as that is. So we're going to have cosine of x, cosine of pi over 2. This is going to be minus sine of x, sine of pi over 2. Then we're going to have minus, and then I better use parentheses because there's a minus sign here. So I'm going to have cosine of x, cosine of pi over 2. Since this is a minus, this will be a plus. Sine of x, sine of pi over 2 equals the square root of 3. So getting rid of our parentheses, we have cosine of x, cosine of pi over 2, minus sine of x, sine of pi over 2, minus cosine of x, cosine of pi over 2, minus sine of x, sine of pi over 2 equals our square root of 3. So the cosines are going to cancel out. That will cancel this out. I will have 2 of these. So negative 2 sine of x, sine of pi over 2 equals the square root of 3. So sine of, whoops, before I do that, I was going to divide, but I might as well substitute in first. What is the sine of pi over 2? Sine of pi over 2 is 1. So looking that up on my table, sine of pi over 2 is equal to 1. You can cancel that out then. Negative 2 sine of x equals square root of 3. Dividing by our negative 2, sine of x equals negative square root of 3 over 2 then. So looking up on our table for where does the sine equal negative square root of 3 over 2, we have 4 pi over 3 plus 2k pi, with k being an element of z, or keep looking at my table, negative square root of 3 over 2 is 5 pi over 3 plus my 2k pi, with k being an element of z. So either 4 pi over 3 or 5 pi over 3 plus my 2k pi, since that's my period for sine, and those should be your answers. 13, 14, and 15, we're using the double angle identities. So again, either you'll want my note sheets or you'll want to go on to Alex and go to the dictionary, type in double angle to get your double angle identities. Sine of 2x is 2 sine of x, cosine of x. Cosine of 2x, we had 3 different versions we could use depending on what we want to have in our answers. And then of course we have the tangent one. Normally, again, we'll just use the sine and the cosine ones, but for the cosine, you've got 3 different choices of what you might want to substitute in. So you'll want to keep that in mind. Hopping back over here then, we have the cosine of 2x minus the sine of x, and so we want to substitute in for the cosine of 2x. And so on my cosine of 2x, since this is in terms of sine, I probably want to use the one with 1 minus 2 sine squared of x. So I'm going to use 1 minus 2 sine squared of x minus the sine of x equals 0. Again, I don't like that to be negative, so I'm going to move everything over here. 0 equals 2 sine squared of x minus the sine of x. No, plus the sine of x, because I would have to move it over. Minus 1. There. So I have 2 sine squared of x plus the sine of x minus 1. That moved over and made it positive. That moved over and made it positive. That moved over and made it negative. So factoring that, since I have 2 sine squared of x, I would have 2 sine of x times the sine of x. I'm going to have one positive and one negative. I want this to be positive, so I want my plus and my minus. 1 and 1. That would give me 2 sine of x minus 1 sine of x, which is a positive 1 sine of x in the middle. So either 2 sine of x equals 1, so the sine of x equals 1/2, or sine of x is going to equal minus 1, keeping in mind I moved those over to the other side, so their sign changed. So looking up in my table, again, these are the ones we're going to use with our 2k pi's and all of those. 1/2. So 1/2 is either at pi over 6 or 5 pi over 6. So pi over 6 plus 2k pi, with k being an element of z, or what was the other one I said? 1/2 was also at 5 pi over 6. 5 pi over 6 plus 2k pi, with k being an element of z. Or sine of x equals -1. Sine of x equals -1, we only have one answer there, 3 pi over 2. So 3 pi over 2 plus 2k pi, with k being an element of z. So those are our answers, keeping in mind that we were doing the sign, so that we had 2k pi over there, pi over 6 plus 2k pi, 5 pi over 6 plus 2k pi, or for the -1, 3 pi over 2 plus 2k pi, and of course k being an element of z. So number 14, same kind of thing. If I can get the board moved. We have the cosine of 2x again. Since we have the cosine of 2x, that this is in terms of sine, we probably want to use 1 minus 2 sine squared of x. So 1 minus 2 sine squared of x minus the square root of 3 sine of x equals 1. We're going to go ahead and subtract our 1. Cancels that out. So we have -2 sine squared of x minus the square root of 3 sine of x equals 0. And again, since I want it positive, I'm going to move things over. 0 equals 2 sine squared of x plus the square root of 3 sine of x. So solving that, I'm going to factor out the sine of x. Gives me 2 sine of x plus the square root of 3. So either the sine of x equals 0, or 2 sine of x equals negative square root of 3. Divide that by 2. So sine of x would equal negative square root of 3 over 2. And we're going to find the solutions to those ones. So where does it equal 0? It equals 0 at 0 and at pi. Those are the ones we can combine. We don't need the 0 in front. We'd have 0 plus k pi, which is just going to be k pi. So k pi with k being an element of z. Negative square root of 3 over 2. For the sine, we would have at 4 pi over 3 plus my 2k pi, with k being an element of z. Or negative square root of 3 over 2 is also at 5 pi over 3 plus my 2k pi, with k being an element of z. So we can come, oops, not quite that far up. We can combine our first two answers, the 0 and pi, into just k pi. And then we have our 4 pi over 3 plus 2k pi and 5 pi over 3 plus 2k pi. Oh, got my pen in my hand. Doesn't want to move the board that way. Number 15, this time we have the sine of 2x. The sine of 2x is 2 sine of x cosine of x. So we have square root of 2 cosine of x plus, and we're going to put in 2 sine of x cosine of x equals 0. So looking at that, I can factor out the cosine from both of those. Cosine of x times the square root of 2 plus 2 sine of x equals 0. So either the cosine of x equals 0 or 2 sine of x would equal negative square root of 2, moving that over, divide by 2. So sine of x equals negative square root of 2 over 2. So where does my cosine equal 0? Cosine equals 0 at pi over 2 and at 3 pi over 2. Again, those two are going to be able to be combined because they're 180 degrees or pi apart. So I'm going to have pi over 2 plus k pi, with k being an element of z. So instead of having two separate ones with the 2k pi, we can combine them and just add 180 each time to get to those ones. 4, sine of x equals negative. All right, my card got full, so just going back here to number 15. Cosine of x equals 0. We had pi over 2 or 3 pi over 2. Those were 180 degrees apart, so we could combine those two answers together. Pi over 2 plus k pi, with k being an element of z. When we looked up for the sine of x equals negative square root of 2 over 2, we had two answers, 5 pi over 4 or 7 pi over 4. So these ones are not 180 degrees apart. We're just going to add our normal 2k pi. So 5 pi over 4 plus 2k pi, with k being an element of z, or 7 pi over 4 plus 2k pi, with k being an element of z. So again, for the cosine equals 0, if you look it up, you have pi and 3 pi over 2, which you can combine together into pi over 2 plus just a k pi. And then we had for sine of negative square root of 2 over 2, 5 pi over 4 and 7 pi over 4. Can't combine those, so each of those have plus the 2k pi on the end. All right, so on these ones, we are solving trigonometric equations using half-angle identities. So if we look up our formulas, our half-angle formulas, sine of u over 2 would be plus or minus the square root of 1 minus cosine of u over 2. Cosine of u over 2 plus or minus the square root of 1 plus the cosine of u over 2. For tangent, we had 3 different choices depending on which one we want to use and what we want in our formulas. So you want to keep that paper handy. You also want to keep your paper handy with your reference angles and what each of those are equal to that we've used so many times already. So if I go back over here, it has the cosine squared of x over 2. So if I think about what is the cosine of x over 2, it would be plus or minus the square root of 1, and that one is 1 plus the cosine of x over 2. So substituting that in, we're going to have 2 minus 2 cosine squared. So I'm going to have plus or minus the square root of 1 plus the cosine of x over 2, but it's going to be squared, equals the sine squared of x. Now when we square this, we don't have to worry about the plus or minus. It's going to be positive. Squaring that square root's going to cancel that out. So we're going to get 2 minus 2, and we're just going to get the 1 plus the cosine of x over 2, because when we squared that square root, it made it positive and canceled it out. Equals their sine squared of x. So we get 2 minus, this would cancel this, 1 minus the cosine of x, because I use my distributive property, equals my sine squared of x. 2 minus 1 would give me 1 minus the cosine of x. Here, since I have sine squared of x, I want to use my Pythagorean identity. The sine squared of x equals 1 minus the cosine squared of x, so that I have the same units. So I have 1 minus cosine squared of x I can substitute in for sine squared of x. I am going to minus my 1, add my cosine squared of x. So I'm going to have cosine squared of x minus cosine of x equals 0. Factoring that, I would have cosine of x times cosine of x minus 1 equals 0. So either my cosine of x is going to equal 0, or my cosine of x is going to equal positive 1. I am then going to look those values up on my table. So cosine equals 0 is at pi over 2, and also at 3 pi over 2. But those we can combine. So pi over 2 plus k pi, with k being an element of z. Cosine of x equals 1 is at 0. That's it. But we would do plus 2k pi. So we are just going to use 2k pi with k being an element of z, because I don't need the 0 in front. 0 plus 2k pi is just 2k pi. So 2k pi with k being an element of z. So our answers, we either have pi over 2 plus k pi to combine those two into 1, or we have just the 2k pi, because 0 plus 2k pi is still 2k pi, with k being an element of z. So not only did we have to use our half angle identity, we had to use one of our Pythagorean identities to substitute in order to solve that all the way. The next one, we're using a sine. So we have the sine, whoop. Now the board's going to be difficult. The sine of x over 2 is going to be plus or minus the square root of 1 minus the cosine of x over 2. If you look up your half angle identity on that one. So we're going to do 2 minus 2 plus or minus the square root of 1 minus the cosine of x over 2, but we're going to square it, equals 2 sine squared of x. So again, when you square this, it'll be positive, cancel out your square root. So 2 minus 2 times 1 minus the cosine of x over 2 equals 2 sine squared of x. 2's are going to cancel. 2, this is minus, so minus 1, negative times a negative would make that plus cosine of x equals 2 sine squared of x. 2 minus 1 would be 1 plus the cosine of x. Again, here we're going to want to use our Pythagorean identity. The sine squared of x equals sine squared of x equals 1 minus the cosine squared of x. So I'm going to have 2 times 1 minus the cosine squared of x. So 1 plus the cosine of x equals 2 minus 2 cosine squared of x. Moving these over here, I'm going to subtract my 2 and add my 2 cosine squared of x. So 2 cosine squared of x plus the cosine of x minus 1 would equal 0 when I combine all my terms. 1 minus 2 would be my minus 1. So factoring that, I have 2 cosine squared, so 2 cosine of x times the cosine of x. End is negative, so one's a plus and one's a minus. We got a plus here and a minus here because factors of 1 are 1 and 1, and we want a plus 1 in the middle. So we want a positive 2 cosine of x minus 1. 2 minus 1 gives me the positive 1 cosine of x in the middle. So 2 cosine of x equals 1. Cosine of x would equal 1/2. Here, cosine of x would equal negative 1. Looking those up on our table. Cosine of x equals 1/2 at pi over 3. Cosine of x also equals 1/2 at 5 pi over 3. Those are not 180 degrees apart, so they're both going to have the 2k pi. Cosine of x equals negative 1. The only place cosine of x equals negative 1 is pi. And so we're going to have to add the 2k pi to that. So we're either going to have pi over 3 plus 2k pi, or 5 pi over 3 plus 2k pi, or pi plus 2k pi. And so all three of those are going to go in for your answer. Pi over 3 plus 2k pi, 5 pi over 3 plus 2k pi, or just pi plus 2k pi, since that's the only place cosine equaled negative 1. One more on the sheet. Okay, so number 18, again we're using the half angle formula for sine of x over 2. Sine of x over 2 is plus or minus the square root of 1 minus the cosine of x over 2. So 1 minus 2 times plus or minus the square root of 1 minus the cosine of x over 2 squared equals cosine squared of x. So in this case, 1 minus 2, squaring the square root would make that positive, so I just get the 1 minus the cosine of x over 2, because the square root would cancel out, equals cosine squared of x. Here my 2's would cancel. So 1 minus 1 plus cosine of x, negative times a negative made that a positive, equals cosine squared of x. Since we're all in terms of cosine, we don't need to use our Pythagorean identity. We just need to set it equal to 0. So 0 equals the cosine squared of x minus the cosine of x. 1 minus 1 would have canceled out. Factoring, we can take out a cosine of x. So we have cosine of x minus 1. And so either cosine of x equals 0 or cosine of x equals a positive 1. So looking up where the cosine equals 0. Pi over 2 and 3 pi over 2. Again, those two are ones you can combine. They're 180 degrees apart. So pi over 2 plus just k pi, with k being an element of z. Cosine of x equals 1. Cosine of x equals 1 at 0. So 0 plus 2k pi just gives us 2k pi, with k being an element of z. So again here we can combine those into 2. They're 180 degrees apart, or pi apart. Here you have 0 plus 2k pi. You don't need the 0 in front. So those are going to be my answers. And that is the end of Chapter 6, Homework Day 31.